Great. All right. Hey, everybody. I'm Gina. I'm from the marketing team here at Provide. I have Ryan, our developer evangelist and SAP architect, with me here today, and we are super excited to share our Chainlink Fall Hackathon submission. He's going to walk us through the SAP Chainlink price feed integration today. So I'll turn it over to Ryan to showcase what he's been working on.
Thanks, Gina. And I'm excited to share our progress today on our Chainlink price feed integration. So if we get started, there's a few terms and platforms I just want to make sure the audience gets to know about before we dive in. First, this hackathon entry is very squared away around integrating to SAP. And if you weren't aware, SAP S/4HANA as a platform is a dominant market-leading enterprise resource planning system used by most Fortune 500 businesses and similarly sized organizations for running their finance, supply chain, and their overall business processes. Here at Provide, we created proUBC, and this is a newly developed software development kit to help integrate SAP to the Web3 ecosystem using the PRVD stack. And it's written in the programming language used in SAP called ABAP. And we're very proud of this entry overall because this is really our first demonstration of smart contract integration between SAP and to using the PRVD and Chain MPI. A couple other tools to know about. Shuttle. We use Shuttle as a low-code designer to enable that Web3 onboarding process into a system like SAP. Further, there's an additional feature to Shuttle, and this is what Shuttle's often really all about, is creating zero knowledge proof based workflows. If you've heard of the baseline protocol standard, that's really the standard we've used to model these workflows upon. And last, of course, is the PRVD stack. This is the API microservices architecture that enables proUBC to connect to blockchains like Polygon and to services like Chainlink and make that a reality into a platform like SAP. So what kind of business problem are we looking to solve? Well, inside of SAP, there are foreign exchange rates, right? Because as you know, there's lots of global commerce that goes through SAP between different companies, B2B, and they have to maintain price information on the US dollar, euro, other fiat currencies, right? However, this process of maintaining that price information can be very vulnerable to poor inputs. It can be hard to automate the process, and getting good price data into SAP can be challenging, and getting it wrong can really hurt your relationship between business partners. Further, a second point here is that if a company wanted to hold Ethereum, Bitcoin, or other digital assets, those types of price information is not available through the conventional price feeds typically available to SAP today. And that would mean that there's some challenges of, feasibly bringing Web3, not from a technical level, but from a business level of keeping the bookkeeping in line to that. And lastly, even though there's a lot of commerce going on inside of SAP systems today, there really isn't a great way to find a way to aggregate that data back to the Chainlink decentralized Oracle network today. And if we could find some feedback mechanisms, that perhaps could be something that would help harden and improve the price feeds overall. Even though they're phenomenal today, there's always ways we can decentralize and improve those even more. So getting into our hackathon entry, What does it do? Well, first thing that our hackathon entry does is it uses a Chainlink price feed from Polygon to update the foreign exchange rates maintained in SAP. And we've designed a configurable process by which you can specify which smart contracts for which price feeds on the network you would want to use for these updates. And the kind of outcomes you could see from this, right? One is you could use the Chainlink price feeds to optimize, purely off-chain business processes. Most folks, when they think of the Chainlink price feeds, they know of like the ETH USD price feed, but you could use this as well for Chainlink price feeds that are available for, as we said, the euro to US dollar, or to the Japanese yen to US dollar, et cetera. And as previously noted, the Web3 business models that were previously infeasible, now that we have price data on different digital assets, it becomes a more concrete reality for enterprises to hold digital assets since they have reliable price data on their books. Second to this is, what do we do once we have that price data inside of SAP? Because once it's in SAP, it's very valuable to verify and share it across partners and back to the decentralized Oracle network itself. So a few of the feedback mechanisms we've created, one is this zero knowledge proof workflow. And what this zero knowledge proof makes possible is that for other business partners in the B2B ecosystem that are also running SAP or other enterprise systems, they can verify against that proof that's been put on the proUBC network. And what this does is it allows the different enterprises to verify that they're in sync with what exchange rates they're using. And as a business outcome, that's tremendously useful for cross-border finance, B2B arrangements, because whether or not the US dollar is worth $1.05 in euros or $1.06 in euros, often that has significant business impact. And if we could find ways to keep in sync on that data, that would be tremendously good for business overall. Our next feedback mechanism is that we generate a file to IPFS, and similar to how this is really the first integration of SAP to smart contracts on public blockchains. This entry is similar in that it's the first SAP to IPFS integration that I know of that was open source. And the reason why we would do that, one is you could use that file IPFS to exchange to partners, but as previously noted, that file in IPFS, this becomes a mechanism by which we could, really bring some more data back into Chainlink of, how our currency is used, not in trading, but in actual commerce. So those are the two things. We consumed the price feeds and found a way to aggregate some data back to business partners and to Chainlink itself. Now we're up to the fun part. This will be the demo, and in a moment here, I will dive into SAP and you'll get a live look at our price feeds integration, as well as the proUBC baseline and IPFS outputs as well. Okay, excellent, folks. I'm glad to be with you here today, and we're going to look at the consumption of price feeds inside of SAP in our development environment. So I just opened up Eclipse, and I'm in the ABAP developer tools for Eclipse, and this is much of the technical objects of our repo for the hackathon entry this year. So you can see my package there. And I've opened this program called ZPRVD Chainlink Price Feed. And you can see I have several entries available here. And I'll just break down very quickly what each of these options do. First, this is a variant. So I'll select this variant, and it inputs a few key pieces of information. One is, what kind of price pair are we interested in today? So we're interested in the Ethereum and USD price pair on Chainlink. This is in the PRVD stack. We give a unique identifier to different networks. This case, it's the Polygon Mumbai testnet that we've identified here. And by the way, we've created an entry in a table that links this ETH USD price pair to a specific smart contract. You can see that actually in a database table known as the ZPRVD price feed. But rather than get further into that, let's execute this. And we'll include those feedback mechanisms, like I said earlier. So we'll create that baseline protocol zero knowledge proof. And we'll also go through the effort to generate a file to IPFS. And come with me and we'll debug some ABAP here as well. Let's go. So quick /h to turn on the debugger and execute. Okay, so at this point, what we see here is this is already up to executing the contract on the Polygon Mumbai testnet. So if I step over this right here, and I look at my API response, here you can see I've gotten that price feed data from the Polygon Mumbai testnet. So there's our outputs, right? There's the round ID, there's our price information, there's some timestamps there as well. So now that we have this data from Polygon, let's step over next to look at what's going to follow after this, right? So we have a few more things to marshal some data around. So we parse that data, and what we're going to do is do some transformation and save that data. We save the price feed results into our own custom reporting table. But after that fact, what we'll do is we do some additional transformation to get ready to update the currency data inside of SAP. So that's some additional formatting that takes place here. Let's dive into this part. Because this is where we're really getting inside of SAP and changing the currency rates inside of SAP. This is a function module that's used typically to update fiat currency pairs like euro and Japanese yen or Canadian dollar. Here we did it for Ethereum, actually. So if we look inside this updated market rates, right? And take a look inside the data, we can see ETH USD that's ready to go there. So after we update that, now SAP has an Ethereum price, ready to use Ethereum as ultrasound money. So we selected that option to do that baseline proof, that zero knowledge proof. So we'll take a look at that as well. So if I dive into this, really we're taking some of this data and getting it ready to do this call to the PRVD price feed sync zero knowledge proof workflow. And this message here, that just fires off that ZK proof. And it can take a little bit of time, so let's hold on for just a moment while that completes. And we got successful status, excellent. So I'm just going to F7 over that. And we successfully did that zero knowledge proof, which is phenomenal. And now we're on to the IPFS part. So What we've done already at this point in the debugger, we've generated that file into SAP's file directory AL11. So all that this is going to do is, reopen that file, move some binaries around and, get it ready to move to IPFS. So that we've created the file and we've got the content, we're ready to transfer it to IPFS there. And this last little bit, this is, a bit of the guts into what we're actually sending, to that IPFS add endpoint. This was tricky. Like I said, this was the first time we've ever done IPFS and ABAP together. But really great that we get a good response out of IPFS here. And yeah, we have a file generated to IPFS. So at the end of this program, you don't have to debug every single time, but here we have some outputs really summarizing what we did. One, yes, we did process that data into SAP. So if I go into, let's open a quick SAP GUI session here and go to the table tcr. And let's say I want to look at the ETH price feed. And I've gotten several other entries today, but here's a result we just got from earlier. This table here, this price feeds results table. This is our current entry that we got here today as well. And yes, of course, since I mentioned it, this is where we configured that price pair ID to a smart contract to the Polygon Mumbai testnet. But let's take a look at Shuttle, because there's some really interesting things going on in Shuttle, right? To create that zero knowledge proof, we use Shuttle to model this workflow, and it's a very simple workflow overall. We defined a domain model that included the fields of the price feed information that we used, and selected general consistency, deployed this. But to review that creation of that ZK proof, here we have it in our console here. So you can see here, this ZK proof all the way here, this is the same as what we really saw as an output over here. Actually, where do I have that up? Should be right here. Yep. So we have that same ZK proof for that information, as well as that file. If I go into SAP and I look at AL11 and I kind of dig around this file directory, this is kind of like a Unix directory that's actually right here. My zoom's kind of in the way there, but if I look inside this directory under data, you can see I have all these different price feed files that I've been executing and running here lately. And if I just jump out of my remote desktop session here a minute, and I look inside of IPFS, you can see my file's been pinned there as well. So there you have it. You have a update of the foreign currency tables inside of SAP. You have a zero knowledge proof that was created and propagated to PRVD network, and you have a file that's been generated to IPFS. Hey, so welcome back, everybody. Hope you enjoyed that technical demo, and I hope that this visual kind of gives an idea of what you just saw, right? So you had Chainlink as our Oracle network, providing price feed information, to SAP, thanks to the help from Polygon and the PRVD stack, their shuttle facilitating that onboarding and that consumption. And also, thinking about what SAP can do for Chainlink. That file that we generate to IPFS, becomes a mechanism by which Chainlink can get even more information of how currencies are used in real world commerce. So if we look here, let's reflect on the impact of this, because if you're not familiar with SAP, it has tremendous impact in the world of commerce. So, uh, over 16 trillion of dollars of consumer purchases, go direct to SAP. So, uh, even though it's primarily a finance system, a lot of order management takes place out of SAP directly. 77% of the world's transaction revenue. So these Fortune 500s, when they, do bank settlements, they're initiated by SAP. And of course, since we mentioned the Fortune 500 so much, really it's incredible capture of the usage of SAP, because 98 out of 100 of the most valuable brands in the world are all SAP customers. But I would say too, like even brands that are very quietly doing boring things in the economy, those as well are often on SAP too. So a bit of a technical summary of what we did. So we created some ABAP programs to consume the Chainlink price feeds from Polygon, and we updated those exchange rates inside of SAP. We implemented that callback to trigger that PRVD baseline proof, and we published that price data into a file back onto SAP, not to SAP, back to IPFS. And what we really doing here is that we made it very configurable. So there's a table entry that if you just wanted to add additional price feeds for Bitcoin or other currencies or even fiat currencies, as long as there's a Chainlink price feed for it, you can just drop that information in and keep going. So thinking about how we could iterate upon this in the future, that update to Tcur, that same mechanism you could use to maintain other financial data inside of SAP. Of course, you could think about ways you could use price feeds for commodities like oil or gold. I know that, for instance, Trueflation is a specialist in that domain. And since you're dealing with a finance system, what if you could use that PRVD proof to do like a zero knowledge proof verifying the bank reserves of an ERP? And of course, we'd love to do additional things with Chainlink inside of SAP, such as VRAF, keepers, and so much more. And really what we did as well is with that accounting problem solved to Web3, solved with the price feeds, now we can think about other smart contract integrations as well. So a few notes of where to find our hackathon deliverables, right? So everything is provided in this Chainlink Fall Hackathon repo for proUBC under this link here. If you look at the README, there will be some additional notes there of using proUBC as a prereq. So we had originally created this, but this hackathon entry is like we spun it out as like a separate standalone thing, but it does require you to set up proUBC. And what's really useful for SAP folks looking to clone these repos and run it for the first time, check out these enablement docs, right? Because that will walk you through not only cloning the repo and doing some first-time configurations, but also give that very visual step-by-step of what you need to do to get the whole infrastructure of SAP and Web3 and PRVD stack and shuttle all nicely aligned there. So a thank you, right? For me, the Provide SAP architect and dev evangelist, would also like to give a shout out to Alex, our Provide full stack developer, hugely influential in helping me make best use of shuttle and PRVD stack. And of course, Gina, our marketing cohort here. And as well as additional thanks to the rest of the Provide team. We have a link to our website. You can learn more about us, as well as the PRVD Open project. I believe Chainlink is also a member of that, as well as Polygon and others. So feel free to check that out. And with that, that concludes our video today. Thanks for checking this out. Take care.